Hi, Sean. Thanks for asking this question. Sorry I took so long to respond to you, but I had to make a lot of phone calls trying to get my grade 10s online, which has been a bit of a struggle. So here it is. Hopefully it helps. It says a 66 kilogram skier. There they are in red. I'm calling the skier Mass A. Initially at rest. There it is. V initial A is equal to 0. Slides down a 25-meter hill. There it is. Y initial 25 meters. And has a completely inelastic collision with a stationary skier of 72 kilograms. So here is the stationary skier. I'm going to call that stationary skier MB, mass B of 72 kilograms, and they're initially at rest. And they have an inelastic collision, a completely inelastic collision, which means they're stuck together as they move forward. That's what completely inelastic means. We want to know what is the velocity of this stuck duo as they just uh, just after the collision. So that's why I'm calling that, oops, velocity final, just velocity final. That's what I'm calling that. And I'm not calling it velocity final A, B, just velocity final as they move away. All right. So analysis. Here we go with the analysis. There's really two parts to this question. Part A is for mass A. As this slides down, we need to use the law of conservation of energy to find out how fast is it going when it gets to the bottom of the hill and is about to hit the stationary skier. So we use the law of conservation of energy here. And that's what I've done right here. Total energy initial is equal to total energy final. And that we know is a combination of kinetic and gravitational potential in each situation. But at the beginning, skier A in red was not moving, so that doesn't have a term there. It's zero, only gravitational potential energy. And that is equal to the final kinetic energy of the skier, which eventually will allow us to find the final velocity for skier A. But it's at the ground level now. So skier A has no gravitational potential energy. Remember, part A is strictly for mass A, the red skier there, the one that's moving to start with. So we write out the expression for gravitational potential energy, initial, and we write out the expression for kinetic energy, final, for skier A. And there's the expression right there. Then we cancel out the mass. We're left with this when we multiply each side by 2. All right. Multiply each side by 2. The mass has been canceled. Then we don't want final velocity for skier A squared. We just want final velocity for skier A. So we have to square root both sides, which leads us to this. Then S is for substitute. We plug in some numbers. We get our handy dandy fancy dancy calculator out and we find the final velocity of the skier A, 22.2 meters per second. Now I want to go back to the diagram. That means when the skier gets to here and just is hitting skier B, all right, that's the speed of skier A, just as the collision is about to commence or is commencing, just at the inset. Okay. Now we move on to part B of this question. Part B of this question is the inelastic collision part of this question. So they are hit, there's a collision, and then they move off stuck together because it's completely inelastic. So here's part B. So part B, we say momentum after the collision is equal to momentum before. Well, momentum after the collision is equal to the combined mass of these two skiers stuck together, which I'm going to call mass AB, times the final velocity of these stuck together skiers as they move forward. This is our unknown that we're trying to solve for. And this is equal to the momentum before the collision. Well, the only thing moving before the collision was skier A. So that would be mass of skier A times speed of skier A final. That means the final as it just came down the hill. As odd as it may look to have a final here, that's what that is. So the final velocity of them together we get by dividing each side by the mass of the combined skiers. So we get this expression right here. Now we move to substitute. And in substitute, we plug in our numbers. There you have it. And then finally, we get a solution. And there's your solution. There it is. Sean, thanks so much for asking. Once again, I apologize about being tardy. Just got uh, busy trying to motivate my grade 10s. You know, they're a little bit younger than you guys in grade 12 that are more motivated. And we'll see you later. Have a great day. Bye bye.